These are in listen-only mode.
Hello and good afternoon. My name is Denise Williams, and I'm one of the tutors in the Math Center at Grantham University. I will be your narrator for today's webinar. Today's webinar is webinar number 5 in a series of webinars discussing how to use technology in a business statistics class. In particular, we will focus on how to use Microsoft Excel's data analysis toolpack, as well as the formulas and functions that are available to solve statistical problems. Today's webinar, we're going to talk about confidence intervals. Now, there are 3 types of confidence intervals that are mentioned in your book, but not necessarily discussed in your lecture. There's confidence intervals about the population mean, about the population proportion, and about the population standard deviation. Today, we're going to focus on finding confidence intervals about a population mean. Before we begin, I just like to remind everyone that I'm working with an Apple MacBook computer, that I'm running something called Parallels on my computer, and so all of the information that I show you will be using Microsoft Excel's 2013 version. If you're running anything else, please contact the Math Center and we can direct you as to how to replicate the results that we will show. Okay, carry on. Now, there's some vocabulary that I will be talking about that I'll be using in today's webinar, including talking about the mean and the standard deviation. Notice that I will be talking about 2 different means, the population mean as well as the sample mean. The same goes for the standard deviation. I will talk about the population as well as the sample standard deviation. We're going to talk about the normal distribution curve, uh, which is also called the Z-curve. We'll talk about the T distribution. We'll talk about something called level of confidence. We'll also refer to point estimates and margins of error. These are all terms that you should be familiar with from your book, from your reading, and I'll just gloss over them as we go along in the webinar. Now, the first, what we're talking about now is confidence intervals about a population mean. A population mean. Now, what that means is you're trying to find a range of values that your mean would fall into for the population based on the sample data. Now, if you know what the population standard deviation is, that would be the sigma that is appearing on the screen. If you also knew that the population came from a normal distribution, or at least that the sample size was large, and that the sample that you picked was a random sample, then you can use the formula on the right, and this is called the confidence interval formula for a sigma that is known, a standard deviation population, standard deviation that is known. What do we see here? This is equal to x bar plus or minus z alpha over 2 times sigma over the square root of n. Now, what do all of these things stand for? We're going to talk about what they stand for in a minute. Before we do that, though, we're going to see how we can verify that a particular problem meets the assumptions that are shown on the screen. Here is an example. A simple random sample of size 35 is taken from a population where the sample mean is found to be 34.2. The standard deviation for the population is 5.3, and we're asked to compute a 95% confidence interval about the mu. Now, the first thing that we have to do before we can compute the confidence interval is make sure the assumptions hold true. Now, let's go back to the first page, the previous page. Here we see that the first assumption is that sigma has to be known. So in the problem, they have to give us a population standard deviation, or sigma, so that we can plug it into the formula. The second is that the population has to be from a normal distribution, or the sample size has to be large. And when we say large, we mean n has to be bigger than 30. The third assumption is that the sample was taken from a simple random sample. Now let's see if all of those conditions hold. The first condition, if you look down at the bottom of the PPT, the first condition is that sigma is known. And from the problem, we see that sigma is equal to 5.3, so the assumption holds true. The second condition says that we must verify that the data comes from a normal distribution. Now, in the problem, it does not say that it's a normal distribution, but the sample size is pretty large. When we say large, we mean that it's bigger than 30. If you look at the problem, you'll see that the sample size is equal to 35, which is larger than 30. So assumption number 2 is true. And then based on the first sentence in the problem, we see that the data comes from a simple random sample. Now all of the assumptions hold true, so we can go ahead and try and plug in the information to the formula. Now we're asked to find a 1 minus alpha percent confidence interval where sigma is known, because the problem gives us sigma. Now this 1 minus alpha percent, what does this mean? We are trying to find a 95% confidence interval, a 95% confidence interval. So where you see the 1 minus alpha, that is equal to the 95%. Alpha will be whatever number you plug in to come up with 95% or 0.95 here. So in this case, alpha is equal to 0.05, and we'll talk about this in detail in the next slide. But first, let me take out the parts of this confidence interval. The first part, the x with the line over it, is called x bar, and this is the sample mean. This is the average that's given in the problem. Let's skip to the population standard deviation, the sigma that's on top of the fraction. Now that sigma, that looks like a sideways 6, is a population standard deviation. And then the n that's in the bottom of the fraction underneath the radical, this is called the sample size. How large is my sample? Now let's go to the z alpha over 2. The z alpha over 2. What does this stand for? The z alpha over 2 comes from our normal distribution table, and this stands for the area under the curve where the value, this stands for the z value, where the area under the curve to the left of that value is equal to, to the right of that value is equal to alpha over 2. This is fun to do by hand, but because this is a webinar that talks about technology, we're going to focus on how to do this in the computer, in Excel. But first, let me show you how to plug in the numbers. So here, we would come up with an answer of 32.44 to 35.96. Notice that the confidence interval has two values. It's an interval. It's telling you that your answer is going to be between 32.44 and 35.96. You will not come up with one number as your value. It has to be a range of numbers. Now, this range of numbers came from this formula. It's a 95% confidence interval, which implies that alpha is equal to 0.05. Remember, we said that for a confidence interval, we're computing a 1 minus alpha times 100% confidence interval. So this is where we came up with our 0.05. Our x bar from the problem was 34.2. Our standard deviation from the problem was 5.3. And our n from the problem was 35. Now, once we plug everything in to the formula, we'll come up with 32.44 and 35.96. Now, why is it that we came up with two numbers? Notice that in the middle of the formula, you have a plus or minus sign. That means that you're going to first subtract from the mean the number on the right of the formula, and then you'll come up with the 32.44. After you subtract that from 34.2, you have to you have to add in the number on the right to the number on the left. So you're going to do two functions, two calculations. First, you're going to subtract and come up with an answer, and then you're going to add and come up with an answer. And that's where we get this from. Now, this is actually very important for you to know that you have to add and subtract, because when we do this in Excel, it doesn't actually give us these, sorry, it doesn't actually give us these um, lower bounds and upper bounds. Instead, what Excel does is gives us something called our margin of error. So let's talk about what the margin of error is. In this particular formula, the confidence interval, 1 minus alpha times 100% confidence interval, where our sigma is known, there are two components that make up this interval. The first component is what's on the left, the X bar. Now, this X bar is called a point estimate. This X bar is called a point estimate. It's also referred to as a sample mean, but we're going to be using the term point estimate with sample mean interchangeably from now on. So please make sure that you understand that. Now, what's on the right of the plus or minus sign? What's on the right of the plus or minus sign? The z alpha over 2 times the sigma over the square root of n. This is referred to as the margin of error. The margin of error. And this is what Excel will give you, the margin of error. And you'll have to use the margin of error to come up with your confidence interval. Now, what is the formula for us to use in Excel? The formula to use is as shown on the screen. If you know what your standard deviation for the population is, you will use the formula confidence, period, norm, open parentheses, alpha, which comes from the level of confidence, what 1 minus alpha times 100%, that alpha, times the standard but not times, alpha comma, the population standard deviation, comma, n. Again, please remember that this formula will only return the margin of error. It will only return the margin of error. Now let's see how to do this in Excel for the information that we have here. Now the first thing that I'm going to do is I'm going to write down what information is given to me in the problem. I have my n value, my x bar, my sigma, and my confidence, 95% confidence level. Okay, now remember this is my formula. So let's go ahead and open up Excel. I'm going to type in the information that I have. I have a point estimate. Remember, point estimate talks about my sample mean, and that's equal to 34.2. Make this a little bit bigger. Whoa, too big. Hmm. Oh, Okay. So I have a point estimate of 34.2, and the margin of error is what I'm going to ask the computer to calculate for me. What else do I know? Let me insert some other things. I know my sample size, and I know my population standard deviation. My sample size is 35. My population standard deviation is 5.3. Now I'm going to find the confidence interval by using the formula that was given in the presentation slide. So I'm noticing that there, when I type in confidence, it comes up with two different formulas. We're focusing on the first one for right now because we know the population standard deviation. So confidence.norm, open parentheses, and then my alpha. Remember that this is a 95% confidence interval. So alpha is equal to 0.05. I have a standard deviation of 5.3. I'm just going to click on the empty cell, and a size of 35 in close parentheses. Now this gives me a margin of error of 1.76. This is not my confidence interval. This is just the number to the right of my confidence interval. What do I have to do with this number? The first thing I'll have to do is to find the lower bound by subtracting this number, the 1.75, from the point estimate, this number. So I'm going to find my lower bound is this minus this, and it gives me 32.4. To get my upper bound, I'm going to add these two numbers. So this plus my margin of error, which gives me 35.9 or 36. So this is the same thing that I came up with by hand when I was calculating over here on my presentation, 32.44 to 35.96, same values. Now let's try for another problem. Here it says, an urban economist wishes to estimate the mean amount of time people spend traveling to work. He obtains a random sample of 50 individuals who are in the labor force and finds the mean travel time to be 24.2. This is for the sample. Assuming the population standard deviation is 18.5 minutes, construct and interpret a 95% confidence interval. So let's go ahead and do this in Microsoft Excel. Okay. So the first thing I'm going to type in is sample size. I also need to have my confidence level, which will give me my alpha. I want to make sure that you understand where the alpha is coming from. Okay, now based on this problem, my sample size was 50. My confidence level was 95%. This is the 95% is the confidence level. This is what's given to me in the problem. I'm asked to calculate a 95% confidence interval. Now, because this is 95%, my alpha is equal to 1 minus whatever this is. Now, 95%, I'm writing it as a decimal, and to find my alpha, I take 1 minus this number. And so this is my alpha that I'm going to use in my formula. The point estimate, this is the same thing as my average, which is given to me in the problem as 24.2. Let me make sure that's true. 24.2. Then I have a population standard deviation of 18.5. And the margin of error, lower bound and upper bound, we're going to use Excel to calculate. So this is all the information that's given to me in the problem. And I'm going to use this information to calculate my confidence interval. So in this cell that's next to margin of error, I'm going to type in my formula. It's equal to It's equal to confidence dot norm, open parentheses, my alpha, which is 0.05, my standard deviation for the population, which is 18.5, and then my size of the sample. So this is my margin of error. Remember, the margin of error is the number that is on the right side of this confidence interval formula. Now, after I use Excel to calculate my margin of error, I'm not finished. I need to go ahead and calculate my lower bound and my upper bound. My lower bound is equal to the point estimate minus my margin of error. My upper bound is equal to my point estimate plus my margin of error. So my final answer is 19.020722 and 29.3278. Remember, I have an interval, and these are the numbers that make up my interval. Okay, now let's go back to the presentation and move on. What we've been doing is we've been working with data that has some criteria that must be met. Remember that we know the population standard deviation, the sigma here. We know sigma. Now, what if we don't know sigma, which is more often the case? If you don't know the population mean, more than likely you don't know the population standard deviation. So we have to use a different formula if you don't know the population standard deviation. And that formula is this one, using the t-distribution. The formula that's on the right that uses the t-distribution. Now, what is the assumptions or the requirements that have to be met for this formula to work? First of all, we need to not know the population standard deviation. So in the problem that you're given, if they don't tell you the population standard deviation, then you will have to use this formula. But not knowing the population standard deviation is not enough. You must also know that the sample size is large. That means n has to be bigger than or equal to 30. This is the normal cutoff that we use. If n is not bigger than 30, but you know that the data comes from a normal distribution, then that's enough. That satisfies this requirement. The third is that the sample has to come from a simple, random sample. The data must be random. And then the fourth is that there's no outliers. Remember that an outlier is an extreme data point extreme value in the data set. Something that's a lot bigger than everyone else or a lot smaller than anything else. I think I lost my mic for a minute there. Okay, now let's go on. Let's look at a problem. So here we have a simple random sample of size 35 that's taken from a population. The sample mean is found to be 108, and the sample standard deviation is found to be 10. We're asked to construct a confidence interval about the mean. Now, what is different from this problem and the problems that we have done in the past? In this problem, they don't give us sigma, the population standard deviation. Instead, focus on the fact that they're giving you the sample standard deviation. Here, it's called S, not sigma. And this S is equal to 10. Because we don't know the population standard deviation, the first requirement has been met. The second requirement is that the sample has to be normal. The population has to be normal. Now, it doesn't say that the population is normal, but the sample size is sufficiently large. It's bigger than 30. It's equal to 35. So we can assume normality. The third condition is that the sample has to be random. And this is stated in the first sentence, that it's coming from a random sample. The last condition is that there are no outliers. And though that's not given here, we're just going to assume that to be true, that there are no outliers in the population, in the sample. Now, if this is the case, we have this information. How would we calculate our confidence interval? Now we'd use this formula. Notice that this is different from the formula that we have used before. Instead of having an x bar plus d, we have an x bar plus t. Where we used to have a sigma, now we have an s. Where we used to have a sigma, now we have an s. So what do these numbers, or what do these symbols stand for? The x bar is the same thing that we've been referring to before in the past. It's the sample mean. The x bar is also referred to as the point estimate. This is the point estimate. The T alpha over 2 is computed using net with n minus 1 degrees of freedom. And this is using the T distribution table that is in your book. But this is a technology webinar, and so we're not even going to look at that table. We're just going to show you how to come up with a calculation using Excel. Then we have S over the square root of n. The S is the sample standard deviation, and the square root and the n is the sample size. Now again, to re-emphasize, because it's very important, the X bar is the point estimate. The X bar, which is on the left side of the plus or minus sign, is referred to as a point estimate, and this is the sample mean. The T alpha over 2S over the square root of n, this is referred to as a margin of error, and this is the number that comes up on the right side of the point estimate. Remember, this is called the margin of error. Now, if you were finding the confidence interval for the sigma unknown in Microsoft Excel, you would use the formula confidence period T, open parentheses, alpha S n, alpha comma S comma n. Now, note that this formula will only return the margin of error. Remember, the margin of error is the number that's on the right side of the plus or minus sign. Now, let's go ahead and do the problem that's on this screen. Here we have n is equal to 35. A sample mean is 108. Our sample standard deviation S is 10. And we're asked to calculate a 95% confidence interval, which implies that alpha is equal to 0.5. So I'm going to go ahead and open up my Microsoft Excel. Go to okay. So I'm going to type in everything that I have for this problem. My alpha is equal to, because it's a 95% confidence interval, that implies my alpha is equal to 0.05. My sample standard deviation given in the problem is 10. My sample size is 35. My point estimate is 108. And the margin of error and the bounds are something that I'm going to use Excel to calculate. So to find the margin of error, I type in the formula confidence dot t. Remember, I'm not using the norm anymore because here I'm given the sample standard deviation. Now, open parentheses, I'm going to type in my alpha value, my standard deviation, and the size of the sample. And this returns a margin of error of 3.44. Now, from this margin of error, we're going to come up with our confidence interval, our lower and upper bounds. So I'm going to take my point estimate, my sample mean, and subtract my margin of error. And then I'm going to take my sample mean and I'm going to add my margin of error. And this is the lower and upper bound for my problem. Now let's go ahead and keep it going. Again, the formula, let me show you the formula just to make sure. Confidence.t, the alpha, the sample standard deviation, and the sample size. Move on to the next. Okay. Now, this is a problem that's similar to a problem that you would have in your assignment, perhaps. Here is a poll that was conducted almost 10 years ago, asking how many books do Americans read. They asked a sample of 1,006 individuals, Americans, during the previous year, how many books did they read? That came up with an average of 13.4 books for the sample, a standard deviation of 16.6, and you're asked to calculate a 99% confidence interval. You're asked to calculate a 99% confidence interval. So what are we going to do with these numbers? Let's go ahead and open up our Excel. And here, I'm just going to type in My sample size is 1006. My sample standard deviation is 16.6. And my alpha, because this is a 99% confidence interval, my alpha, instead of the 0.05 we've been using, is now 0.01. The point estimate is a sample mean, and that's equal to 13.4. Now this is all the information we're going to need to come up with our margin of error. So I'm going to type in the formula confidence dot t, open parentheses, my alpha 0.01, comma, standard deviation, comma, sample size, close parentheses. And this is my margin of error. To find my lower and upper bound, I'm going to take the point estimate and subtract, and take the point estimate and add. So these are my final answers. I have a lower bound of 12.05 and an upper bound of 14.75. So Americans on average. The interpretation of this, I think I'll leave that for you to work out through your reading. But just to come up with the numbers we have here. Let's move on to the next to last problem. This one is about dividend yields. And this one we'll see is a little bit different from what we have been working with before. How so? Here we have a lot of information, but the information is not in the problem itself. It's not written out for us. Instead, we're given raw data. So a stock analyst wants to estimate the mean dividend yield of financial stocks. So how much money is he getting back? What percent is he getting back? He obtains a simple random sample of 11 financial stocks and obtains the following dividend yields. We're asked to construct and interpret a 90% confidence interval for the dividend yield of financial stocks. Assume the data follows a normal distribution and there are no outliers. So here, this data is normal. There's no outliers. So we have to make sure that the assumptions hold true. The assumptions hold true. So let's go back to the assumptions page for this. Now the assumptions are that my sigma is unknown, which is true. I don't know what standard deviation for the population is. Also that the sample has to be large, or it has to come from a normal distribution. The sample has to be a simple random sample, and there cannot be any outliers in the data set. So let's look at this data again. Go back to our data and make sure that all of the conditions hold. Now the first condition is that sigma is unknown, and that's true. I don't know what sigma is from this problem. Population standard deviation. I only have sample data. Second condition is that the sample has to be large. Now this sample is not large. There's only 11 numbers, but it tells me that the data follows a normal distribution. The second to last sentence says it's normal, and so that's good enough. The third condition is that the third condition is that, what's the third condition? Let's go back to that. The third condition is that the sample came from a simple random sample. So let's make sure that's true. Yes. From the second sentence, we see that it's a simple random sample. And then the last condition are that there are no outliers, and that's given in the last sentence. So now that we know that all of the assumptions hold, we can go ahead and calculate the confidence interval. So what we have to do for this one, it's a little different from what we've been doing before, is we put in the raw data into Microsoft Excel, which I've done already. So these are the numbers. I've just copied them over into Excel. Now, once I have the numbers copied, I still have to come up with my point estimate, my margin of error, my lower bound, and my upper bound. Now, how do I do this? I can do it two ways. The first way is a way that we have done before, like from the first webinar, we talked about how to find the average of the data set using Microsoft Excel, and so we can use a function, the formula function here, average for this data set, which will come up give us our point estimate, and that's there. We can also come up with our standard deviation for the sample. Which is standard deviation for the sample. And then we can, based on these formulas that we have done, we've used in the past, we can now come up with our margin of error by typing in confidence dot t open parentheses our alpha. Remember, this is a 90% confidence interval, so my alpha is 0.1 standard deviation, and then my size, which is 11, because there are 11 data numbers. So I come up with a margin of error of 0.55. Now, what do I do with that? I use that with my point estimate. So I'm going to take my point estimate and subtract 0.55, and I take my point estimate and I add. So I come up with a lower and upper bound of this 0.76 to 1.87. Now, there's another way. I said that there are two ways for us to do this. So this is method one. And I'm going to show you method two. So method two, before we show that, let's see the steps. So go back. If you're working with raw data and your standard deviation for the population is unknown, you can also use the data analysis toolpack. This toolpack, we talked about how to install it in the first webinar. So if you have not installed the analysis toolpack add-in, please go back to the first webinar and see how to do that. Now, this analysis toolpack is also just going to return the margin of error, but it's less work than what we did. Even though what we just did was not a lot of work, we can even do less work. And so that's great because you want to do less work. Now, this will give us the margin of error. And from that, we can find our lower and upper bounds. So the point estimate is the same. We have to use the average function to come up with our point estimate of 1.31455. But the margin of error, we can find that by going to the data section. Remember, this is Excel 2013. Go to our data section, and then on the right, you should have the data analysis. Now, when you open data analysis, you're going to go to descriptive statistics, and click OK. You will click on where it says input range, make sure that cell is highlighted, and then click and drag. I don't have any labels, so I'm not going to click this. My output range, I'm going to say where I want my answer to go. And I just want the confidence level for the mean. So make sure that I click this. Now, this is a 90% confidence interval, so make sure I change that to 90%. Click OK. And this is the number that I need. Yep. So this number is the same number that's here, but I didn't have to find the standard deviation. That's really the only thing that's different. I didn't have to find the standard deviation. And I didn't have to plug in the function, but I still have to find my point estimate. So the reason why I need to find my point estimate is because I need to use my point estimate to find my lower and upper bound. So again, it's the same thing that I have here. I'll come up with the same answers. I take this number and I subtract this number, and I take this number and I add into it the second number. So my answer, two different ways. This is the data analysis toolpack way, and then this is the functions way. So let's go back through that again. This one, first I took the standard deviation of the sample. Then I found the average of the sample for the point estimate. After that, I used the confidence function formula, and then I added and subtracted to get my bounds. For the method 2, remember I used the data analysis toolpack. I went here, go to descriptive statistics, press OK. Make sure that you highlight the raw data. You say where you want your data to show up, your answer to show up, and that the confidence level adjusted for whatever you're trying to find. We're going to do one last problem just to make sure you got it. Okay. Now, this one has to do with crawling babies. This is also a raw data set. The following data represent the age in weeks at which babies first crawl, based on a survey of 12 mothers conducted by Essential Baby. Assuming the data comes from a normal population and that there are no outliers, construct a 95% confidence interval for the mean age at which a baby first crawls. So we have a sample of size 12. We have 12 numbers. We have a 95% confidence interval, which means our alpha is 0.05. We have no population standard deviation because we only have sample data. We also don't have an average. We have to calculate that on our own. Now, based on this information, let's go ahead and plug it into Excel, which I already have actually here. So we have our 12 data points, and we are calculating, let me go back and see. We're calculating a 95% confidence interval. Remember to check the assumptions. It comes from a normal population. The data is normal. There are no outliers. And we're going to assume that this data was was random. We're going to assume it's random, even though it's not listed here. Because if it wasn't random, we couldn't do this. So we're just going to assume it's random. Now, the data was transferred here to the Excel spreadsheet, and I'm going to go ahead and work the problem. So we have our point estimate. Our point estimate is equal to the average of these numbers. Our margin of error is equal to, well, let's find what it's equal to. I'm going to go ahead and use the analysis tool pack. So data analysis, descriptive statistics, okay. A through A14. Output range, okay. And it's a 95%. So I have a confidence interval, a margin of error of 6.35442. I copy and paste that there. Now I have a lower bound of the point, this minus this, and I have an upper bound of this plus this. So my final answer, I have a confidence interval between 31.9 and 44.6. I have a confidence interval between 31.9 and 44.6. Alrighty, so this was fun. Now to review, if in Excel, in Microsoft Excel, if the problem gives you the population standard deviation, so you need to know two things, population standard deviation or the sample standard deviation. You need to know what are the differences between the two. If they give you a population standard deviation, you will use the first formula on the screen, confidence.norm. If they don't give you the population standard deviation and instead you are given the sample standard deviation, you must use confidence.t. If they give you raw data, that means that they give you a bunch of numbers and you have to calculate the average and the standard deviation on your own. You can also use the analysis toolpack under descriptive statistics. Please note that this analysis toolpack is only used when you're calculating the confidence level about the mean if you do not know the population standard deviation. You cannot use it for when you do know the population standard deviation. It assumes that sigma is unknown. Okay, I think that we've done a lot today. If you have any questions, please don't hesitate to contact us at the Map Center. We can help you if you have any questions installing the analysis toolpack. Please go ahead and contact us at the Math Center. If you're running anything besides Microsoft, if you're working with a Mac like I am, please don't hesitate to contact the Math Center. It was great. Have a wonderful evening and talk to you later. Bye-bye.